Let's... All right, I'm so sorry that we can't fit everyone in. We will try and get a bigger theatre again. I guess some of the online people have showed up to the face-to-face lecture because we have exceeded capacity now. I'm sorry, this is such a small theatre. At least it is air-conditioned, so there is a benefit of that, unlike your graduate school welcome, which was not air-conditioned very well at all. Welcome, everyone. Welcome to your first day of uni for some of you, which is really exciting. And welcome to COMP1511, which, I don't know, arguably best course. I don't think anyone can argue with me, though. If you would try. Okay, so there's a lot of people asking if they're online, can they attend the in-person lecture? We're going to try and increase the size, perhaps, of the theatre, or we're going to also try maybe get another theatre where the live stream can come through so that you still get the benefit of being with others in a lecture, which is part of the fun of uni, I guess. Okay, so let's get started. Okay, so today, what are we going to do today? Today is going to be probably the most boring lecture of COMP1511 you will ever go to. And that's because I have to tell you all the information for the term ahead. And then from then on, things are going to get a lot more exciting. So sorry in advance. Okay, a little bit about me. I am your lecturer this term, which is really, really exciting. I love term one. This is probably the most people I've seen face-to-face in about 3 years, which is also really exciting for us because face-to-face lectures are really fun. Yep, so I love dogs. I don't know if everyone knows that, so you'll get a lot of problems that somehow involve dogs. And I really like solving complex problems. I also like to talk about the design of interfaces because just because you can code doesn't mean that you will make something that someone can use. So lots of fun. I do have 2 dogs, Jax and Juno. They often appear in questions and in problems that we do. I have been trying to smuggle them into university for a very long time. They have gotten close. They've kind of on the edges of K17, but someone always spots me and I have to turn back. So there we go. All right, our admins this term are the lovely Tammy, who's just sitting on the floor over here. That's how we treat our admins in 1511. And the lovely Ben, who's still doing his internship, but will be back next week. Tammy and Ben will be answering a lot of emails. You'll probably see them around a lot and they help out a lot. So you will have a few things to do with them and they are the ones that help sort things out in the course to make sure everything runs smoothly. Also, we have the lovely Sophia and Tom, who are the lecture moderators yet again. They're also on the floor and enjoying life, obviously. So I guess we'll see how well Sophia throws in a bit. And Tom, I don't know, last term everyone kept trying to remake your name. I tried a little bit as well. Not as good, obviously. Tom was part of the SunSwift team that just set the record, which was very exciting. So he's had a good summer. Sophia, not so much. She just worked full time. So she's probably glad to be back here. Okay, the wonderful tutors, I was trying to put it together, but I ran out of time, so nothing happened. There are no photos of all our wonderful tutors. One of them is right here on the floor, Jack, and he probably used his bike to get here, so that's pretty... Did you? No. Oh. I'm wearing that shirt, though. Okay. Oh, you're wearing a bike shirt. Well, at least something. Thank you. Good. At least that. Okay, so we've got a wonderful team of tutors. There are 50 of them this term. You will meet at least 2 or 3 in your classes that will be with you for the rest of the term. So they're really all very nice. And you can go to our webpage where we introduce ourselves, meet the team, and have a look who is your lovely tutor. Okay. Now I would like to find out more about you. I have been reading your introductions on the forum, but I would like to know more. So let's do a quick game. Not creepy at all. No, I just want to know more. I want to know who the students are. for all the important questions, and there will be 10 really important questions. You will not be judged for your answers, unless with the dogs or cats one, you might be judged a little bit. So if you can go to this and... All right. It's just up here. Yeah. Oh, yeah, sorry, I moved the QR code out. You just have to log in now. Dogs or cats? The all-time important question in life. Dogs or cats? Well, I know what your choice is. You've got 2 dogs. Oh. Oh, dogs are winning. That's what I like to see. Tammy's a bit scared of dogs, she told me, but she doesn't mind them, apparently, as long as they stay far away from her. Oh, dogs for the win. Although I have seen some cute photos of cats on the introductions on Ed. What if you like both? I mean, it's true, you can like both, but surely you like one a little bit more. Gotta choose, gotta choose. I used to have a cat as well. There we go, but I do like cats too, but I like dogs a little bit more. All right. Dogs are taking the win in this theatre. Okay, superhero, supervillain. Oh, got a lot of people that are going to make trouble in this course this term. My gosh, lots of supervillains. Wow, definitely supervillains. All right, interesting. Okay, are you a night owl or a morning person? The CSC, I wonder which one's going to win. Yeah. It's always a non-contest at CSC. But I like to... Oh, a few early birds. Not too... Oh, gosh, really not too many. And guess what? Now that you're no longer at school, you are welcome to lead your best nocturnal life. That is a very solid win for the night owls. All right, Mario or Luigi? What's that? Oh, they're a close one. Waluigi. Oh, close call, that one. Chocolate ice cream or vanilla ice cream? This is definitely how you just judge a whole person. Equals. Sorry, I don't have any fancy flavors on here. What do you call it? Soccer or football? Oh, this is my pet hate. Oh. Okay, I've had this argument with many people at CSE. It's a sport where you literally touch the ball with your foot. Come on, let logic prevail. It's football. All right? Do you cook things or do you burn things? Lots of people that cook things, but lots of people that burn things as well. Do you like to camp or do you like to be at a hotel? It's not both. It's never both. You got to choose this or that. Choose. Choose. I'll take being in a tent any day. Come on. All right, not a lot of people liking to camp. Sweet or savory? Oh, wow, savory. This is a surprise. I think last one, Game of Thrones or Lord of the Rings? Interesting. All right. Well, that was very informative. Thank you for that. It's a bunch of night owls that like to go to hotels, that like to burn things, that prefer dogs. That was amazing. That now all our questions can be formulated around those. All right, we do not use Moodle in this course, okay? So you do not, there is Moodle, you can go to Moodle and all you'll see there is a website that redirects you to our course webpage where we do everything in. And I think Tom has kindly pasted it in the chat as well, the course website address. We do everything on this course website and then we use the terminal, which we will talk more about later today, to submit assignments, to do auto testing, to do coding. So we are old school. So that is our course webpage. For any admin related issues, you please email the course email for all the admin related inquiries. So sometimes if you email me, there's a lot of emails in my inbox. It takes me ages to get through them often. But if you email the course account, there is a few people checking it so that you will get an answer much faster. And the email for that is cs1511@unsw.edu.au. For any enrollment issues, unfortunately, we cannot help you with enrollment. We do not have access to the enrollment system. You have to go to the nucleus. And I suggest visiting them or calling them because they must also get a lot of email and they don't reply to them as quickly unless you go to them or see them or call them. If you have an equitable learning plan, please feel free to email me or Equitable Learning will do that for you as well. And you can email it to me directly. Okay, the forum. I think I saw quite a few of you have joined the forum. I didn't look this morning how many were actually on already and how many are still waiting to get on the forum. So that is the best place ever to ask questions because you get to crowdsource answers. But also we have people checking the forum quite regularly, so you'll get a much faster response as well. You are also obviously welcome to ask questions in your TUTE labs. You are also welcome to ask questions in the lectures. You can post them in the chat if you don't feel comfortable just asking them out loud. You can join the YouTube stream and just ask them online there. And help sessions. Help sessions will start in week 2. And you will be able to ask any questions you want at the help session, mostly related to your code, I hope. And it's a great place to get help outside of normal lab and tutorial times. All right, so what is COMP1511? I mean, it's the best course you'll do at university. A lot of my tutors are nodding. I don't pay them for that. That's definitely just them. Thanks, Tom. It is our Intro to Programming course, and this is where you kind of start to see whether you really do like programming or maybe not so much. So this is going to be your answer to, is this what I should be doing when I graduate, I guess. So basically, this is where we teach you how to program and how to solve problems in C. And we'll talk more about C in a second. So computers are smart, but they're not that smart. Well, they're getting smarter, but they're not that smart. They can only follow the instructions that we give them to solve the problems. So we are the ones that give them the instructions, and to write those instructions, that's basically doing the coding part of the problem. Now, the hardest part about coding is actually solving the problem without the code first. And you will see that the syntax is one thing, but actually problem solving is another. That's the hardest part of this course, is learning a whole new way to solve your problems. Well, not your problems, just the problems that you get given in class. Okay, we assume no prior knowledge. We assume 0 programming experience. Actually, Tom, can you run a poll now? I just want to see if people have programmed before, out of interest. How do people feel about raising their hand? Do we feel comfortable doing that? How many people have programmed before? Shower of hands. Wow, okay. Okay. Okay, there we go, quite a few. We assume you know nothing. And so the first few weeks we go slowly. And then often students will say that in about week 4, we pick up pace quite a lot. So try not to fall behind. So we are very gentle in the first few weeks and then not so gentle. So we are going to try and teach you, maybe we'll see if you've got any bad habits, because bad habits are hard to break. Okay, so lectures. You found the theatre, so obviously you know it's live in CLB6 and streamed online via YouTube. Mondays 11 to 1 and Thursdays 12 till 2, so you get to spend your lunch times on both of those days with me, which is exciting. Week 6 is Flex Week, which means you don't have any lectures, you don't have any classes, you get to relax. That is not true, as you will find out at university. It is really the week that you catch up on everything and on your sleep, I hope. So hopefully that will be the case. If you have questions, please feel free to ask in the live chat. The one thing that I will say, both in the chat and in class, please make sure that you're respectful to everyone around you, respectful to the other students, respectful to the staff. Everyone is here to learn, and everyone is here for the same reason, so please be respectful of each other and make sure you look after each other and support each other. Oh my God, who is in the chat saying Haskell is the best language? Jesus, Haskell is not the best language. Absolutely not. Okay, so in the lectures, we've got our theory, so we're going to do a little bit of what is it that we're actually talking about. What are we trying to understand? We're going to do a lot of coding. So it is nice if you have your computer with you, you can code along with me. I will have live code. It will update every time that I save, and you will have access to it. So you can actually copy that code in and paste if you're running behind, and you can break it, and you can try different things with it as well. So that code will be available to you as well. We're going to talk about problem solving. We're going to talk about debugging code as well. And basically, we're just going to have some fun. It's not just going to be me talking at you. We're going to be actually solving problems as well. Lecture slides are available from our course website. They're uploaded usually the night before the lecture. Often I will forget to give the right read and write permissions, so you will not be able to see them. Just tag me in the forum if I have done that, and I will fix it straight away. Okay, and lecture recordings will be available in the YouTube list and linked via the course website. Tutorials, they're going to be your lovely 1-hour classroom environment, and they are much smaller, so there's going to be 21 of you, 22 of you, I can't remember, because it increased a little bit and then it decreased. So about 20 people in the tutorial. You're going to go more into depth in the topics that we're teaching. It's a great place to ask any questions. It's a great place to form little groups where you get to know the people around you as well. And it's a great place to start solving problems with your tutors and with your peers as well. And again, all available on our website. Okay, there are some tutorials that are online only, and there are mostly face-to-face. So you would have enrolled in either an online one or a face-to-face one. For the online classes, we are using Teams, and you should have been added to a Teams team. So if you haven't, let us know, and we will make sure that you are in the right place for your tutorial, because some of you have your first tutorial straight after this lecture, which is so exciting. For those of you online, if you've got pets, we like to see them. And we do release the answers after the last tutorial of the week. Your tut hour is followed straight away by the lab 2 hours. And the lab is the practical component. It's where you actually get to solve problems. So you get given coding problems and you head out into your lab and you code. We do not expect you to have finished all of those problems within the 2 hours. Lab problems are due the following week, so you actually have that lab time and another week on top of it to, well, not for some of you that have the later classes. So they're due the following week on a Monday. So for those of you on a Friday, start early. Not as good as the ones that have classes on a Monday. But the labs are an excellent place to talk to your tutors one-on-one. If you have a problem that you can't solve, they are there to help you. There is 2 people in each of your labs, and they are willing and excited to be able to talk to you. There are also, so there's a varying number of problems each week depending what else we have going on. So in assignment weeks, we try to do a few less problems so you can focus on your assignments. Other weeks, there's a few more exercises because we want you to get a lot of practice. So all of the problem sets, they're marked automatically. And you have to pass the auto tests for them, and we'll talk more about that as we talk about what it looks like. And it's 15% of your total course mark goes to those lab problems over the course of, the 10 weeks, the 9 weeks, the 8 weeks even, because the first one is just your practice one. For those of you that feel comfortable, there are challenge exercises every week usually as well that are not worth any marks. They're just for funsies. So if you want to do those, you are more than welcome to also do those. And there are no classes in week 6. Okay, assignments. Our assignments are hard. Maybe not the first few stages, but the last few, they get a lot harder. And they are there to challenge you on a larger scale, but also to make sure that you get enough practice with the topic and you get to kind of code and break enough things that you get to understand some of these hurdles. So it's really important that you start the assignments early. The help sessions get really, really packed towards the due times, and there's often very long queues. So please make sure to start early, because then you can get help early from a whole bunch of sources. You can ask in your lab, you can ask in your tute, you can ask in the help session, and there's going to be a few more things going on before assignment due times. There are 2 assignments this term, assignment 1 and assignment 2. Assignment 1 is usually released in about week 4 after we cover arrays, and it's due in week 7 on a Monday, which means that I have just eaten up your whole flex week and you will have to code instead of relaxing, which really is relaxing sometimes. Unless you have a bug, then it's not relaxing. And assignment 2, which is worth 25% of your overall course mark, and it will be released sometime in week 7. We'll give you a few days to relax, lull you into a false sense of security, and then we will release assignment 2, and that will be due at the end of week 10. Late penalties are 5% per day late, and we apply them from the ceiling of the mark. So that means if you are 1 day late, the maximum mark you can get is 95%. If you're 2 days late, the maximum mark you can get 90%, and so on and so forth. And the maximum lateness is 5 days. We do not accept submissions after 5 days. Okay, help sessions. They are really, really packed often towards the assignment due days. We do put extra people on the help sessions to make sure that we get to help everyone, but please, please, please start your assignments early. That's what I want you to walk away today. Even though the first assignment is not released till later, I want you to walk away and be like, I've got to start the assignments early. We will release the help sessions in week 2, and that's when we'll start them. We'll release the timetable for it as well, so you'll be able to see what's going on. The ones that are running online will run on Teams. I haven't activated the team, so I'll activate that after the lecture, so you'll be able to see where you're at. And there will be a schedule on our website soon, and I'll make an announcement about that. Okay, this term we're also piloting something called PASS. PASS is peer-assisted study sessions. So we don't organise them, the university organises them. But we tell you about them, and they are basically little study sessions that run a few times a week. I believe we've got 4 sessions for COMP1511. Each of those study sessions has a group leader, and you get to kind of go in there and try and get help with specific problems from lectures or tutorials or labs. I note that they do not help with assignments, so you will not be able to get help with assignments. Those start in week 3, and you can register for those if you think that that would be useful to you. I've provided the website for more information about what this program is, and I'll put it in an announcement as well when it gets closer to starting. Okay, we're also, because I like to keep things interesting, we're also doing an optional feedback and reflection module. You might not use it as much in the first 2 weeks. There's not that much to reflect on as you kind of make your first forays into code, but you'll be able to submit a piece of code, and a tutor will actually have a little chat with you about it. They'll tell you perhaps you're doing something wrong, something right. You'll be able to reflect and have a little bit of a chat about it. We're going to add you all to Formative, so you have an option to do that if you wish, and I will talk more about it as well in an announcement. Okay, so final exam. Everyone always, oh, that should not say take home open book exam. I should have, it is not that. I'm going to cross that out. It is absolutely not that. Just ignore that bit here. I'm not sure what that's doing there. Especially when I wrote here in capitals in person. I like to juxtapose. It is an in-person exam. Woohoo! Yeah, it was so fun this time. It was good. No, it was good. About 3 hours is what the exam takes in person. We are usually one of the first exams scheduled, so we're in the beginning of an exam block. So that's a positive thing, and that's because we've got a lot of marking to do after the exam. You'll be given a series of problems to solve using C, not in a surprising development since this is a course about C, and you will be also expected to read some C and understand it. So the exam has 2 hurdles in it. You must answer a question using arrays, and you must answer a question using linked lists, and you must pass both of those questions. And that's because the 2 expected learning outcomes from this course that you will carry on through to the rest of your degree is the knowledge of those 2 data structures, arrays and linked lists. And we will do lots of practice to solve those as we go through the course. All right, total assessment. The labs are 15% of your mark. The assignment 1 is 20%, assignment 2 is 25%, and the final exam, the piece de resistance, is 40%. So to pass this course, you must score a total of 50 out of 100 overall. You have to solve a problem using arrays, and you have to solve a problem using linked lists in the final exam. I'm also going to mention that I know a lot of you have come from school. You are probably quite high achievers. You're used to getting very high marks. At uni, if you get a 75, that's considered to be a fantastic mark. Okay, so just, you know, keep your expectations. I'm sorry to say this. My dad's favourite saying used to be, "Please get degrees. Please, just go and relax somewhere. Stop studying." So please, please, please make sure that you look after yourselves. You need to get good sleep. Please eat. Please don't forget to hang out with your friends. Please don't just study the whole time. I beg you. Oh, good. Look at this. Eunice WIT. Okay, special consideration. If you happen to fall ill during the term, which does happen and will happen, and you cannot get yourself out of bed because you're really not feeling very well at all, or something else has happened that has impacted your ability to study, please do not suffer in silence and struggle through it. Apply for special consideration. Got the website up there. If you're unsure throughout the term what you should do, just send us an email and we will redirect you to special considerations. They will give you an extension, which means that you have a bit of downtime and you have time to actually get better properly. Please do not push through it. And if you have an equitable learning plan, then please email it to me directly so we can set up and support you as well through the course. There are supplementary exams available for this course given for medical reasons. So if you can't show up to the exam, if you wake up on the morning of the exam and you don't feel well, don't come to the exam. You apply for special consideration and you get given a supplementary exam. The university has something called a fit to sit rule, which means that if you show up to your assessment, you declare yourself fit enough to do so, and you cannot apply for special consideration after that. So if you are waking up and you are very unwell, do not come to the exam. Just apply for special consideration. The same thing applies for assignments. If you have given it in, it's assumed that you have said you're fit enough to submit that assignment and you're well enough to do it. Okay, and the exam, the supplementary exam, we don't know the timetable yet. It will come out. The university will release when they're running the sup exam window. I estimated it to be sometime in May, which is kind of around the time when it was last year. Okay, code of conduct. I've mentioned it before. We expect that everyone respects everyone, but at the university, we allow all students to learn regardless of your background, your situation. So please do not kind of get in the way of someone else's learning. Please be respectful of everyone else. We do not tolerate discrimination of any kind, no inappropriate behaviour, no harassment, bullying, aggression, or sexual harassment. We will step in and we will deal with it. So please, if you are experiencing anything like this, please let us know and we will deal with it. Full respect for others, please. Okay, I guess every lecture has to go here. Plagiarism. Who knows what plagiarism is? No one? Ah! We're going to die here. Okay, plagiarism is basically using the work of others without saying it is the work of others, pretending that it is your own. The best way to avoid plagiarism is to do your own code. Plagiarism is a huge thing. We check for plagiarism, and we will then talk to you if we detect plagiarism. Can result in your marks being 0. Any serious plagiarism gets referred higher up in the university, and it can lead to quite severe penalties. In first year, I like to maybe more focus on making sure that you understand what plagiarism is before we kind of enforce and move you to more the serious repercussions. But you cannot copy someone else's code. You cannot be a nice friend. We've had this happen in the past. You can see your friend struggling through an assignment. You give them your code. Please don't do that. That's considered plagiarism, and you will be penalized for that as much as your friend that you gave them the code, even though you tried to do something nice. You are welcome to speak to the person. You're welcome to discuss how you're solving the problem. It's okay to talk like that, but you cannot share code that you have written. So please be careful of that. We will come back to plagiarism around assignment 1 time. Okay, so obviously the internet has a lot of resources. There's a lot of coding resources. You can use small sections of code that someone else has written just as long as you reference them. So if you took something from Stack Overflow, please write that in a comment above that code. Obviously it can't be a 100-line event, but it can be 5 or 10 lines of code that you have looked up and you've researched and you've decided that that's the best way to solve something. So, make sure that you always reference something, and please don't ask someone else to solve your code for you or give, and don't provide your code to others. Okay, if you want more information, course webpage is a great resource, also the course forum. These lectures are recorded, and you can replay them as YouTube streams. We can also ask help from your tutors during the one-on-one classes and the help sessions. Any serious issues, if anything is affecting you in the course, you're not sure what to do, please email us. We really care about your well-being, especially in first year as you're making the lovely transition from school to university, where really you are in charge of your own learning. We don't control what you do and where you go. It's up to you to kind of manage your own time. So please let us know so that we can help you. Okay, this is some of the services that the university has available for students. So obviously the slide is available in my lectures, but if you ever need help, you can refer to this. So university has mental health services that you can register for. It's all free for students. We also have if you need to report any sexual assault or harassment, if you need any educational adjustments, which means that you have perhaps an ongoing issue that requires special adjustments to be made, you go to the Equitable Learning Unit. If you need some academic skills, they often run workshops that tell you how to reference things, how to write things better. There are some useful things there, and your special considerations, which is if you are not feeling well, that's where you apply for special cons. Okay, so learning is hard. I do like to do this spiel, even though you're all feeling enthusiastic and probably ready to code. But learning programming is not that easy, and please don't feel like you are not doing a good job if you're struggling through it, especially in the first little bit. It is a slow effort, it is a conscious effort, and it's not simple. Programming is not easy. You're not only learning a new language, so like imagine just learning a foreign language. That's exactly what you're doing. You're also learning a whole new way to problem solve, whilst also adjusting to life at university, which is a complete shift from when you were at school. So please don't be hard on yourselves. Give yourselves a pat on the back. You're here, you're ready. There you go, Tammy, thank you. And you know, quite a few of our tutors didn't have such a great time in COMP1511. I mean, they had a great time, just like a party time, but they found some problems hard. I know that a few of them have told me, they spend hours trying to solve the assignment, a few tears, a few But, you know, they got through it. They did well. It's all about the effort that you put in. But sometimes even putting in effort, you need a break, right? You can't just push it until there's nothing happening. So take breaks, make sure you go and sleep well and eat well and just relax as well. Okay, so let's have a little break. Oh, we're doing such good time. We'll have a 5-minute break and then we will come back and we'll start actually talking about C, which is the more exciting part of it. All right, everyone, let's get back to it. I've just realised in-person lectures have to finish at 5 minutes too, which I've forgotten about. Okay, what is a computer? Who knows what's a computer? Oh, this is a good opportunity to ask questions. Okay, who knows what's a computer and would like to volunteer their answer? Even though I'm displaying a bit of an answer over there. But who wants to define to me a different answer? Yes?
It takes in different inputs, so like some kind of data. And from there I can process it, so doing some calculations, or making use of it. And I can store that information, so I can also output the information.
Fantastic. Ah, thanks. Ah, yeah! First answer, first question, amazing. And first chocolate thrown, perfect, perfect, perfect. Just your accuracy, Sophia. You've been practicing during summer. Amazing, okay. I don't even know if we could really do any more than that. Some trivia, and then I cut that because I included it at the end of the lecture. Who knows what was the first No? Who knows how much the first computer weighed? I mean, if you read the lecture notes, you probably do. Oh, who knows? Someone in the back! Woohoo! Someone knows how much the first computer weighed. Yes, it was the ENIAC, and it did. Oh, Tom! No, I think you were too short. Oh, Sophia. Oh, I'm sorry, Sophia. Another more exercise for you. But that was a good throw, Tom. I'm impressed. It was very close. All right. So a computer is the ultimate tool in its ability to calculate things, maybe. That's just one of the reasons. But there is a lot more reasons for it. But the key elements are that there is a processor to execute our commands, and there's a memory to store information. So that's pretty nice. We do need memory. Okay, what is programming? Oh, why do I keep doing this? I should go back. It's too late now. Oh, I should have asked this. Okay, what is programming? It is where you are the one. You get to have a bit of a power trip and you get to provide the instructions to the computer to execute, which is quite exciting. And you will use a specific language to write those instructions. We will use C. I think I did. Has anyone used C in here before? It's not a commonly one used. Oh, a few people. That's nice. For those that have used C, have you played with pointers? Ooh. Oh, very exciting. Oh, well, you'll be excited for week 4 then. Okay, excellent. So at the core of it, programming is just being able to solve problems. And, you know, you will go through many iterations. You will really live for those memes which show just people with their heads on keyboards. We used to replace the keyboards in the labs quite often, actually, because people would get a bit upset and start sort of... so there were always sort of keys a bit missing. Mistakes are good, though, because you actually learn a lot when you make mistakes in coding. You often learn a lot more when you're debugging code than when you just do clean code straight up and you pat yourself on the back, walk away. You might have made a mistake, but it all compiled and you don't realize that. So when we make mistakes, we actually learn a lot from them. So it's okay to make mistakes. I strongly recommend it. Okay, what's an operating system? And we're going to be using has anyone used Linux in here? Few people. Who uses Mac OS? Let's just see it. For the win, usually. Who uses Windows? Oh, that is a lot of people using Windows. What is happening? The world is changing. Okay, so an operating system, all of you, like Mac OS, Windows, Linux, and so on. Basically, the operating system is the interface between the user and the computer hardware. It's what allows us to communicate. And it executes the user programs, it makes problem solving easier, and it means that we can use our computers, basically. So we need an operating system, and we use Linux in this course. Linux is open source. It is quite reliable. It doesn't I mean, you've all used Windows probably, so it's a lot more reliable than that. You don't get the blue screen of death. And you don't seem to get the Mac spinny, the ball of fire, whatever it's, I can't remember what it's called, the beach ball. So lightweight, it's faster, it's more secure as well. And this is what you will be using. You'll be using the lovely Linux. So should we, let me show you how it, okay, I'll stop doing manic pacing now. Okay, so when we program, well, not even, you don't have to when you program, but we use something called a terminal. Who's used a terminal before in here? Oh, quite a few people, my goodness. Okay, that's quite a rarity. Terminal is basically a command line interface. Didn't do that. I don't know who did this. What you will figure out by the end of this term is that every room on this campus hates me. We will short circuit at least once, the lights will go off, the microphones will break, the screen will fall off. It's all happened. Okay, so terminal command line driven. Windows, Mac OS, they're all graphical user interfaces, so you move around them, you can see exactly what's going on. Terminal is the ultimate power trip. It's where you have to remember commands, you put them in, you get commands back. It's just so you feel like you are basically, God amongst men, because you can do amazing things on the computer. So when we have our terminal shell, we basically have a terminal output, which is the whole window, and it allows us to do user input, and it allows us to display the output. And then we run something called a shell inside that terminal, and a shell is a program that actually executes the commands, and it has its own syntax. So inside the shell, there is a prompt. That was a lot less than 20 minutes. That was like 2 minutes. I would really prefer the lights on. Thank you, room. Okay, so the prompt is controlled by the shell, and it's the line of text that you'll see. It will display some information, and then that's where you will be putting in your commands to the terminal, and you will be controlling the computer through that. All right, let me open up my terminal, and I will I'm going to use, this is what you will see in your labs today. I'm going to run it through the virtual lab that CSE has set up. So you will do all of these steps to configure and run it in your labs this week. Okay, so you will use your ZIDs. You will see me type something weird in here because I actually went to university here a long time ago. And back in those days, a long time ago, back in those days, we at CSC decided we're going to be super special. We do not believe in ZIDs. We're going to get our own names. And so I still have mine from that time. It never got cancelled, even though I was not at university for a very long time in between when I was in industry. So that's why you will often see my shell prompt and everything where I log in with a different name, not my ZID. All right, so you will see something like this, which will allow you to kind of access everything that you need to. You will set this up in your lab, so it will run this virtual lab on your computers, and means that what you're doing is you're connecting to our CSC servers. So you can keep all your files on our systems, and you have access to all of our auto tests, that means, and you have access to our Give system, which is how you will submit the assignments. Okay, so then you will see a little selection of icons at the bottom, and a few of them that you will need to know. This one over here is the terminal, so if you click on it, you will get to see the terminal window, the shell with the prompt as well, and then you can run a whole bunch of commands. And now I really regret this because I think I haven't tidied up my desktop. There's two people in the world, two types of people, ones that keep a neat desktop, and ones that call things tests. Test 1, test 2, test 3, and I am the second type of person. So unfortunately, you're about to see that because I forgot to tidy it up. All right, so there is a whole bunch of commands that you will kind of see and use as you kind of go along, but you might also be using, I'll show you. Okay, so this is the same folder as I am in right now. So I'm inside AVAS 605, and that's where I'm sitting right now. So the first command we'll do is ls, not in capitals, which means list the structure of the whole thing. And you'll see it's just going to give me all the directories and files that are sitting inside that home directory. So what that means when I say directory is that is a folder, basically what is now commonly known as a folder. Same thing, collection of files inside a directory. I've got colors set up, and so what that means is that my directories are in a different color. I really hate these lights. Let's try this. How about we go to 25% lights? Maybe it feels like it's too bright. Okay, so that's going to be, nope, didn't like that. 50%? Maybe, let's see, 10 minutes. Should hopefully last. Okay, so that's our first command. What happens if I want to go into a let's actually make a directory, first of all. Okay, the command to make a directory, mkdir, very clever, make directory is what it is. And let's make one, well, why not? Let's just call it test. And then last time you gave me Spice Girls, which, do I still have it? No, I didn't. No, I still have it from last term. I said, Sophia, quickly, give me a directory to make. And now I have on show to a lot of people a directory on my root called Spice Girls. So this one is going to be test. So once I've made it, it's going to appear both in my folder here, where it is. There it is. It's now in here, just there. And if I run the list command again, it will also be in here as well, just over here. So I've made a directory. How do I go into that directory? So to go into it, I press CD. Well, I type CD, which means change directory. And then I type the name of the directory I would like to go into. In this case, I want to go inside test. Excellent. I am now inside test. And if I type ls to list out the contents, I will see nothing because there is nothing in there. And if I go in here, there is nothing in here. So I'm not lying. Okay, the lights have gone off again because why not? And now, how do I go back to the home directory? Who knows how to go back? Yeah, CD. Okay, what if I type CD? How do I go back with just one directory? Up. Yeah, CD ... takes me up once. CD takes me back to my home. If I want to know where I am right now, I can type in pwd, print working directory, and it will give me my whole where I am located right now, which can be somewhat useful because, again, you are using just terminal commands to kind of orientate yourself and direct yourself around. And just get ready, you will become an overuser of ls. It's just going to become like the most basic command that you type non-stop. I often, moving between windows, lots of chats on Teams, just get an ls, even though that's not where I want it to go. Okay, so those are just a few of the commands that you will run on the lovely Unix. Oh, look at this. We can do moving and copying as well. Should we do that? Why not? Okay, let me make a file inside this test directory. So I'm going to change directory to the test again folder, and I'm going to go inside there. All right, might as well talk to you about what we're going to use to write our code. Okay, a lot of you have coded before. Who uses VS Code in here? Quite a few, okay. We use a very slimmed down version of VS Code. It is going to be something that it's just going to be one window. It's so super slimmed down. A few people on here are using as well VS Code. So to run a file, to make a file, and let's make a text file, why not? I will type in code and I will type in, oh God, this is just not the creativity with the names. Okay, I'll run it, and what will happen is it will open up Visual Studio Code and it will create this file for me called testing. Okay. Let me write something in the file, and then I'll save it. And what you'll see now, if I run ls in this directory, I now have a file called testing, and you would have seen it appear in here as well in the actual folder. There are people in the chat suggesting that Vim should be used. I don't know how, not even I'm that old. Come on. Okay, so that's creating a file. What happens if I now want to get rid of this file? Who knows? Kill. Kill. Who knows what the command is for deleting a file? Oh, Sophia, get ready. RM, yep, okay, beautiful.
Heads up.
And over there, that was the, yep, everyone said RM. You can just do more, come on, I've got a lot of, okay, if I do RM and I'll name the file and I press enter, that file is no longer there and it's disappeared. Magic, magic, magic. So I typed all that welcoming and hello for nothing. Someone wants you to throw a chocolate through the screen. We're not that clever yet.
Yeah. Just come to the
Well, they might be sitting outside.
Maybe your tutor will.
Yeah. Someone is killing all. Okay, so RM. What happens if I now don't want to, I don't really want this, well, I should just kill testing, shouldn't I? Because Spice Girls or test. I'm going to kill Spice Girls as my directory. So, hey? Yeah, now out of context, or the test one. Okay, who knows how to remove a directory? Anyone?
RM minus R.
Very good. What that does, the minus R means a recursive removal, and what it does is it removes the whole directory and all the files in it. So if I remove, I'll just go test because that's the one that we made. If I remove it now and I go back here, it's not going to be in here anymore. Test is now gone. There is something called test code because I do like the name test. So that's now gone, and if I press ls, it's not going to be in here either anymore. So I've removed that directory. Someone's asked, how did I create testing? I will tell you how I wrote code, and I wrote testing.txt. So I basically called up VS Code with the command code, and then I named a file name, testing.txt. And then that one is gone. And then I saved it, which created the file for me. So once I saved it, it's going to be in here now, testing.txt. Okay, I'm going to remove it again. Okay, and when you're inside these, you might have noticed it completed very quickly. It's not because I typed that fast, but it's because I'm pressing tab and it finishes the name for me. So you can press tab as a shortcut, which helps to finish the name of the file that you might be typing, and it means that you move a lot faster through the directories. If you press the up arrow, it brings up your last commands that you kind of ran, so your most recent commands, so that means you don't have to type things again. This is very useful when you get to running auto tests. Okay, that's pretty good. Okay, so a few people asked what we use, if they can use, a few people have actually asked if they can use a tablet to do the course with. You can in theory. There are things that you can run on it that allow you to run VLab. I have a tablet that I run VLab on, however I use it in emergencies. I do not recommend doing the whole course on a tablet. You're going to really struggle to kind of, first of all, it can get a bit slow. And second of all, there is just not enough screen real estate to allow you to really kind of be able to see what's going on. On your own computer, the VLab will allow you to access all of our resources at CSE. It will allow you to store all your files on CSE. What that means is please don't do things on your local directory, or if you do on your local machine, move it over to the CSC servers, because we back up our servers, and you would be surprised how many times people have lost everything because it wasn't on our servers. It was on their local machine. So please, 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 and as soon as you run any auto testing, then we will back up your work as well. So we make sure that you don't ever lose your work. Although 2 years ago, there was a situation at CSC where you logged in and all your files disappeared, and I was one of those people affected. But unlike everyone else, I was really excited because that was like 20 years worth of test and test 2 and test 3 that I really just needed to get rid of and not hoard. Okay, so there are other things that you can run. Okay, sometimes VLab will get very slow, and then you might be in the middle of doing the last bits on your assignment and you really can't handle it running. You know, it will run one auto test, 20 minutes later you're still sitting there waiting for the output. And that's because the server might be overloaded and a lot of people are using it at the same time. So there are other things that you can run. You can run VS Code with an SSH extension and a whole bunch of other things. So those are all on the home computing website, and you can get help setting that up if you need to as well. So we do have other things that we run, that allow us to run this virtual lab as well. Okay. We use a compiler. You're probably going, who knows what a compiler is? A lot of people. Sophia, you ready? Okay, let's go somewhere in the middle. Oh, well, you've got your hand up. Go on. What's the compiler?
It's able to translate the code that we put in to a language that the computer can understand.
Amazing. It is our perfect translator. It translates what we can read into what the machine can read and execute. So it creates our file for us. Okay, who knows what is usually used to compile C code with? In the back of the audience. GCC is usually used to compile C code with. However, we will not use GCC because GCC is really hard to understand on the output. So if you've made a mistake somewhere in there, especially when you're playing with memory, it'll just give you a segmentation fault as the only explanation of the error, which is very hard to interpret if you've just started coding. It will also allow you to go through without warning you if something is slightly wrong, and there are a few things wrong. So what we use is something called DCC. DCC was made in-house by the lovely Dr. Andrew Taylor, who will be doing a guest lecture in week 5 for you, and in week 7 he made it. It's genius, because I will actually be away that week spreading the gospel of DCC at an overseas conference. So DCC is an amazing thing. You will love it, maybe not, but really it's going to be a biased opinion. You have to love it because you will have to use it. But what it will do is it will explain all the errors a lot better for you. It compiles in much the same way. You just use DCC. And then you compile it in the same way as GCC. We will compile something towards in probably the next 5 to 6 minutes to see what's going on. And then the result of that program when you run DCC is going to be a program that we can actually run. And again, if you're using your local machine, it's highly unlikely you'll have DCC set up. It is open source though, so you can get it set up. But we prefer that you use it on our CSC service where everything is already set up for you. So glorious, 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 glorious. Okay, so we are going to be using C, which in my humble opinion, I shouldn't give my opinion. Obviously, it's the best language. What other languages do people have written code in here? Python? C#. Rust. Rust is just, Rust. No, it's good for scripting. I do agree. It is a lot faster. Anything else? Swift. Oh, music to my ears. Someone's using Mac OS. HTML. Don't forget to close your tags. This is how I break the website all the time. This is really mixed up as well, sorry. Okay. Anything else? Oh, yeah, okay. We've got a few here. JavaScript, okay. Oh, C#, yeah, we've had a few C#, nice. Amazing, people are really using it. Tammy, if you're trying to be discreet, it's not working. Yeah. Okay, we've got someone saying assembly. Oh my goodness, that's very low level. So C is a high level, low level. It was sort of the highest low level language you can have basically, because C still allows us to control the memory of the computer, and it doesn't abstract any of that knowledge away like let's say Python. So it's quite rare that in your introductory course you will get to use C, so we are special. But what it means is that you get straight away to play with memory, which is, I don't know, exciting and scary all at the same time. But it's nice to be able to see what the computer memory is doing and how you can control it. So it's going to be a very good starting point as well to how to control everything. And really, once you learn C, almost every other language is somehow based on C. So really, C is the mother and the father and the brother and the sister. C is like an amazing language, again, in my humble opinion. Okay, let's do some C. Why not? All right. And we've got a bit of a pun thing happening here as well. Lots of people in this course, lots of the tutors love pun. Okay, sorry in advance. I'm going to shift into a directory where you can see the code that I'm going to be doing. Struggling because I did ls. My God. Okay, let me change into it. Okay, so when I do this piece of code, when I open this file, what you will also be able to see is it will go in here where it says lecture code. It will appear in here as well once I save this file that I create. So let me create this file and then you can see it appear. Okay, so no intro to programming lecture is ever complete without doing hello world. I think that's just a standard greeting. So why don't we do that? So I'm going to create a file for it by writing hello. And the code command will bring up VS Code, which is the editor. And then I'm going to call the file hello world. You will see that it's got a .c extension, and that means that I'm writing a C file. So if I press enter now, VS Code will open for me. Okay, and once I save it, you will be able to see it on our website. Maybe. Maybe not. I forgot to go into week 1. That's why. I forgot to go into the right directory. See, I didn't realize how organized I would be. So let me remove this file that I've just made. And just so organized. Okay, I'm inside week 1, and now let's do it. Okay, let's try this again. Okay, now I'm going to save this. And let's have a look now. There we go. It's in here. And you will see this often because I will often forget to give access. So what I'm doing next, you don't have to understand or know. I'm just changing the access of the file. Okay, and what it means is that you will now be able to see it, and it's got nothing in it, which is why you're seeing a blank screen. Okay, so that's where you will find the lecture code, and we will kind of continue with that. So most of the time in the lectures, I will have very little slides and more code, and I will write inside the code file as well. So just warning you, that does happen. Okay, so how are we going to structure our code file? In C, there is a few things that we usually do. Okay, the first thing that we do is we try and get you into some very good habits, and we try to have you have a header on each file that you write. Okay, what a header is it's basically like a title of the document. It's telling us what on earth is going on. So you'll see me do those 2 slashes, and they basically say to the compiler, do not read this, skip over this. This is for a human only. This is not for the machine. So this is how I am going to do a comment, and I'm going to write what this program is. So it's a program that, hello world. Okay, and you might write your name, and you might write, I don't know, the date. It's not T3. I've elevated us to the next, to just 2 terms ahead. So done. Okay, that's the header of the file. Okay, and I might just write. Okay, so this is lovely. I've just used 4 of these. There is another way to do comments that span multiple lines. If you're going to be spanning many lines, what you can do is you can do a slash and a star. And then when you're ready to finish, you can do a star and another slash. And anything in between here is a comment. So you can do it like that as well if you wish to do that. Okay, so I'll save it so that everyone can see it on here. So if we go to our, back to the browser, you can see that it's all appearing in here as well, so that we can use all of that. Okay, fantastic. So that's the first part of the file. Now, the next part of the file is specific to the lovely C, and it's your hash includes. Okay, in this particular file, in this particular program, what I'm going to ask C to do is I'm going to ask it to print something out on the terminal for me. Now, when I print something out or I read something in, it's the input output. And what I'm doing here is I'm calling a library that C already has for me. So what that means is that print function that I'm going to call has already been written. I don't have to rewrite it. I'm just going to call something that someone has already made, but I need to include it within my code. So when you use this hash include, what it does is the compiler will go and find this library that I have asked it to include, and this is considered to be a standard library in C. So the compiler will go and grab this library and put the code kind of on top of the readable file, so it's got it all there for you. The compiler does all of that for you. All you have to do is tell it what to include. So hash include, I'm including, and then inside greater than, less than symbols, this stands for standard input output. And .h is because it is a header file. And we will talk about more of that multi-file and what a header file is later on. For now, you don't really need to know the actual definition of it. What you do need to know is not to forget to include it. But we'll see what happens if we do forget to include it, because DCC will kindly remind us and respectfully remind us to include it. Okay, fantastic. So you've done the second part of this program. So I'm going to comment on top of here. Now you, in your code, absolutely do not have to write so many comments. I will write a lot of comments in the lecture. That is not the way we write nice code. You definitely don't want to open code that has thousands of comments on the most obvious things. The reason I do it in the lecture is because we want you to learn from the beginning. So I want you to be able to see exactly what I'm doing step by step. So in your real life, do not write so many comments. Only write comments where they're needed, and we'll talk more about that in the next few weeks as well, exactly where they're needed. Okay, excellent. Okay, so now we have our hash include. Okay, who knows? Well, we haven't really gone through a lot of chocolates. No. Let's do some more. Who knows what I do next?
Int main.
Yeah, I do int main. Now, who knows what on earth that means? Great, int main, what on earth is happening there? What on earth does, out the back, yeah. There's two people. Who wants to, you can describe the int for me. What does the int mean? It does mean that it will return an integer. We will talk more about that in a second. And then what does the main mean? It is a function. Why is it called main? C will always start reading in main. Okay, so you might have many little functions in your code. And C will be like, well, I need to know where to start reading. So C will always start reading in main because it's the main function. It's where we call everything from. It's our main. And so what we do, int main, it's called main. C will start reading in there. And what you'll see me do is you see me use this type of annotation. So lots of brackets. Get used to brackets. They will haunt you in your sleep. You're always going to be missing a bracket. It might be a curly bracket or there might be an extra one. So brackets is your new nemesis. Okay, who knows what that means when I put void in brackets? Hang on, it is empty, but what over there, yeah? Yes, I take no inputs. I start running, and over here, Sophia, as well. I take no, so I return something, but I take no inputs. So the return is over here. It means I return an int, and I take in whatever I say to take in over here. This is just like a quick lesson on functions, which should really be in week 3, but whatever, we're doing it, we're going with it. For now, all you have to know is that this is the syntax for starting to write your very first function. And this week and next week, you'll be writing everything inside the main, so that will be easy. So this is how you will start all your code. Okay, fantastic. And then I've got some really, I don't know why I want to say cute curly brackets. They're just curly brackets. They're not cute. They're just... So you've got two curlies, okay? And the curly brackets are there to say what is going inside here. They denote where that main function starts and ends. So this is where it's going to start, and this is where it's going to end. And what that means is that inside our lovely computer memory, this is how it's going to go on the memory. It's going to go on the memory when it enters here, and then it's going to get off our pile when it comes out of there. And we'll talk more about what that means in a little bit. You don't need to know it yet. You just need to trust me and believe me, which is hard to do. You should also question everything that I say. Yep. Okay, so we have something that allows us now to create a little function inside it. Okay, let's have a look. Should we create a little function? Okay, I'm going to use something called printf. Okay, what on earth is printf? You might be. Sophia doesn't know. If she's your tutor, that's not a good sign. Who knows what printf stands for? In the middle there. It does. It's a print formatted, yep, and it prints out something to the terminal. That is a function, the definition of which lives inside the standard input-output. And what it means for me is that I get to be super lazy and I don't have to write the code to actually print something out to terminal. It's already been done for me. I just call this little function and I ask it to do it for me. So when I call this little function, I then put the inputs to it inside these round brackets, and then I will put my string literal. So what I wanted to print out, I'll put it inside 2 quotation marks. Okay, hello world. And then I finish each statement in C with a semicolon, another thing that will haunt your dreams because it's easy to forget to do them. Okay, excellent. So we now have a printf, hello world, fantastic. Now in here, in this little function, we have this thing called int. I'm literally doing a lesson on functions. I'm sorry. We'll do it again. Don't worry. Don't worry if you haven't picked it up. We're going to do it again. But what it means is you have promised the compiler that you're going to return something from this program, and you're going to return an int, which means an integer. So often we will finish our main function, and this is particularly true for main. We will return something from this main function, and we will return 0. Okay, so this often comes up. When you return 0, and this is just standard kind of lingo. Well, if you return 0, what does it mean that you've returned 0? Let's see who knows, actually. Yeah. I shouldn't pick you because I really can't hear what you're saying. Yeah, okay. And 0 means that you have gone through successfully, no errors encountered. Who knows what 1 means? I bet you do. Go on. Yeah, 1 means error encountered. And you know what? It's just a way to standard classify for us what is happening in our program. So when you return 0 from a program, you're just noting down everything is great. I'm a genius, no errors were encountered. If you return 1, something has happened. In fact I can return whatever on earth I want. I can return 130, 15, 16, 17. Doesn't matter as long as it's an integer. But it won't mean anything. So we use this 0 and 1 to denote success or no success. Okay, I'm going to return 0 and to say this is going to be successful, nothing has happened. And sometimes you'll need to return multiple things inside statements, and we'll talk more about that as we get further into it. Okay, I've saved it. Let's see what happens when we run it. Okay, it's inside here. Okay, here we go. So right now it's a .c file. A .c file is created by humans. Well, I'm human. And it's created for humans, which means that you can read my .c file. I want to make it into 1s and 0s that the computer can read. And so I'm going to use my translator. I'm going to use the compiler. I'm going to call DCC. So this is how we compile files. And then I'm going to say to DCC, what am I compiling? I'm compiling a file called helloworld.c. And this is really annoying because I'm just going to stretch this out. You don't need this anymore so that you can see it on one line. Okay. Now, I'm going to compile this. Who knows if I just leave it there, what file will be produced by the compiler that I can then run? Yeah. It will be, exactly. A file called a.out will be produced just over there, Sophia. Just there. Now, oh, who knew? You got an injury as well in 151. I think you might have to go again, Sophia. That one just fell on the floor.
Where are we?
Oh, and I was like, you've been practicing. It's been a good summer.
I'm a computer science. Oh, no.
Oh, my God, Sophia. Okay, you're retired. Tom, you're on.
You're up.
I'm sorry, everyone, in advance. Potentially. The person still hasn't got one, but we've hit every person around them. Oh, they don't want to damage anyone else around them, I think. Okay. So an a.out, I'm just going to run it so that you can see what gets produced. Okay, so I've run it, and if I do ls and list it out, what you can see is it's produced an a.out file. Okay, I can run it now if I want. So to run things, you do a dot and a slash, and then you do this file that has been produced. Okay, and what it will do is it has run this printing out to terminal. It's printed out hello world. It looks horrific, definitely not aesthetically pleasing. Also, this is just also not that aesthetically pleasing. So what I can do is I can actually tell it what to call my output file so that I keep things neat. Because if you have multiple files in here, which I will after next lecture, they all produce the same file, a.out. So I'm going to keep overwriting that a.out file every time I compile any file. So what I want to do is I want to run DCC. I want to tell it which file to compile. Then I'm going to use /o extension, which means I'm going to specify next what the name of the file is that I wanted to produce is. and then I'm going to specify the file. I just told it to call it hello world. You can call it whatever you want. And what it means when I run that, and if I do ls now, it's going to produce an output file called hello world, which is a lot easier to remember because now the output file has the same name as the C file, which means I can actually understand that they're associated. And I run it the same way. So /, and then the name of the file. And then if I run it, I get this beautiful hello world, which is hideous. All right. Now, that looks horrible. My eyes are burning inside my head. I would like to move my prompt over to the new line. Who knows how I would do that? \n. It is \n. Very good. Yeah. Maybe just hand to her. Oh,
See, I can do it.
that was almost a miss. I felt that. That was
But
like,
also, that's the point.
okay, it's true. Okay, it's true. Okay, in C we use a \n. Okay, it is a special character, and this lovely character allows us to do a new line. So if I go back to my VS Code, and if over here I put a \n, I'll save it, and then I'll go back here, and you have to compile it again, so I'm going to compile it again, and then I'm going to run it again. And let's see what happens now. How exciting. I'm now one line over. Amazing. So that was quite exciting. What else can we do that's fun with this piece of code? What else should we do that's fun? Tom's eating a chocolate. It's a flake, I bet. I knew it when I got the flakes. I was thinking Tom's going to eat them all. Okay, what else can we do? Or maybe we should do some escape characters. Okay. What happens if I want to be a bit tricky? For loop, my goodness, not yet. Calm down, people, calm down. Make a calculator. Geez, it's the first lecture. Not yet. Next lecture we are going to do variables. Hey? Oh, God, not yet. Okay, what happens if I want to now print a sequence of characters? What should I print? What happens if I want to print like this? It's not liking it much, is it? It's giving me a little red. What happens if I compile? Let's have a look. Oh, actually, I do want to show you something. Let me just comment that out for a second. I want to show you what happens if you don't include the standard library, just so that you know what error to look for. Okay, so if I don't do the #include and I try to compile it, it will give me a warning here. And this is DCC working for you. And a reminder to read what DCC tells you. It will tell you implicitly declaring library function printf, and the DCC explanation is that you're calling a function printf on line 16, but DCC does not recognize it as a function because you've forgotten to include stdio.h. So DCC literally tells you what you've done wrong and how to solve it. Okay, so it just reminds you what's going on. So please always read the output. Okay, so let's include it again. Okay, now let's do an escape. So what happens if I want to do this? And it's not happy with me right now. Let's see if we want to compile it, what it will do for me. Okay, it's just throwing me like a, what are you doing? You're crazy. It's saying missing, it just doesn't know what I'm doing. Expected expression, bracket missing maybe, it's struggling. And then even the DCC is saying make sure that all opening brace symbols are matched with a closing brace. Okay, who knows how I can fix it? Oh, there's a few people, 2 people that know. I feel like I've asked you a lot of things at the back there, but oh, is there anyone else I haven't asked? Someone in the middle there that I haven't asked anything? Yeah, in the middle. Tom? Yep. Yes, very good. Okay, what happens if I add one more backslash? Okay, let's try that. Let's see what happens now. Okay, let's compile it. Well, it's not complaining to us anymore, which is very nice. So now let's try running it. So I'll do a // and let's run the program. And look at this. there is a backslash in the corner there. If you can see it, it's just saying, hello, I'm here. So sometimes there are some special characters that we can't really put into our string literal, and then we need another backslash to be able to help us with it. And you will see that a lot in your lab, where you will be doing an exercise, actually not this week, this week, yes it is this week, where you will be doing a lot of that. And a few people in the chat also knew that you just have to put an extra backslash. Okay, excellent. All right, excellent. So we've done that, we've done that, we've done that. Oh my gosh, we've done it all. We have piled through this lecture. How amazing is that? And there is a little bit of trivia for you. That's the first computer in the world. It was in a giant room, and it took many days to actually solve a problem. All right, thank you all so much for coming to the first lecture. I hope to see you all on Thursday, 12 till 2.